first things first, I want to change this series in here so you can cross out these fractions. We're going to make this the quantity n plus 1 cubed. It's better than squared. You say, wait a minute, that makes it more complex. Well, a little bit, yes. All right, just keep in mind n plus 1 cubed is n plus 1 times itself again. And if we were to expand those binomials, we would end up with n cubed plus 3n squared plus 3n plus 1. I'm betting that you'll take my word that this algebra is correct. So just to keep the video short, let's put this right in here. Really what we're looking at here is the sum as n goes from 1 to infinity of 2n plus 1 over this polynomial right here. n cubed plus 3n squared plus 3n plus 1. So we're going to find the limit again. We change colors, just like we did in problem 30. Our numerator will be the 2n plus 1 over the n cubed plus 3n squared plus 3n plus 1. In the denominator this time, you may have an idea what to pick, and if you do, great, and if not, no worries. You will shortly. And go with 1 over n squared. So if we do the same math we did right above, we're going to multiply by the reciprocal of the denominator. So we have 2n plus 1 over n cubed plus 3n squared plus 3n plus 1. So we multiply by n squared over 1. Same math as before. We're going to distribute up top. So we have the limit as n approaches infinity of 2n cubed plus n squared over n cubed plus 3n squared plus 3n plus 1. Think about this limit. You know what it's equal to. 2. Okay? So what happened here? We, once again, found the limit of series that we didn't know over series that we do know. The series that we picked was 1 over n squared, which is a p series, where p is equal to 2. Since 2 is bigger than 1, we know that this series will converge. So, we compared our two series. We know that this one right here converges, big C, and by that limit being equal to 2, we know that this series will also converge. And again, it's going to converge by the limit comparison test. Now remember, when you determine whether or not a series will converge or diverge, you don't have to give the reason, you don't have to give the test that you're using. You just have to come up with an answer, converge or diverge, on the AP exam. So if you kind of think about it, let's look at the two problems that we just did. The first time I picked 1 over n, the second time I picked 1 over n squared. Why did I do that? Well, in your head, you're probably thinking, wait a minute, this was n cubed over n to the 4th, right? Which would, ignoring the 2 and the 3, because they don't really matter for this, which simplifies to 1 over n. If you do the same thing down here and just look at the leading terms, we have that 2 to the n over n cubed, which is going to work in a very similar manner with 1 over n squared. The 2 doesn't really matter for this overall, but notice that the difference in the degree is 2, and the difference in the degree is 2. That's why we picked n squared. Because when we have these polynomials over each other, right, we're really looking at the difference between the degree of the numerator and the degree of the denominator. Up here, the difference was 1. So we used 1 over n to the 1st. Down here, after I made the change, the difference was 2. So we used 1 over n squared. So if we were to actually look at using the limit comparison test for number 32, what's going on here? At the end of the 5th, at the end of the 6th. Those are really the key parts to this. And what does that simplify to? It's 1 over n, which we know is the harmonic, and we know that it diverges. This would be the ideal series to use. Right? When we do the math out, you'll end up having 4 n to the 6th over 5 n to the 6th, right? And with more crap. But ultimately, that's all that matters as n approaches infinity, which is the 4/5. So we're picking that p series that allows us to get the same degree in the numerator and denominator after we multiplied by the reciprocal. Right? So yeah, so 1 over n would be a good series to use here, because you know that it diverges. And that allows us to quickly see that this one diverges as well. So with the limit comparison test, it's really just about picking that good series. And the good series will be some kind of p-series that will work out, or perhaps a geometric series instead. That's the idea behind the limit comparison test. You come up with a ratio that works, and then you know that both series will converge and diverge. On the exam, again, they may not necessarily have you use the limit comparison test. They could, right? But they may just ask you, what does it entail? They may give you a multiple choice question, and you have to look basically for, how does it work? When you're looking to find this as one of your 4 answer choices. I know they both converge